Hi everyone, in this video we're gonna talk about hybridization of atomic orbitals, sp3, sp2 and also sp hybridization of carbon. So let's take a look at word hybrid. It is a blending of two varieties. For instance, a mule is a hybrid of horse and donkey. So what exactly is hybridization? Hybridization is basically combining atomic orbitals to make hybrid orbitals. For example, when two atomic orbitals, s orbital and p orbitals, combine together, they form hybrid orbitals. Please consider only orbitals has a slightly difference in their energy level can undergo hybridization, and the number of hybrid orbitals formed is equal to the number of atomic orbitals involved in the process. Why do we need to study hybridization? Well, hybridization of atomic orbitals shows molecular geometry or the shape of the molecules. And secondly, it shows bonding of atomic orbitals. Carbon is a perfect example showing the value of hybrid orbitals. As we know, carbon's ground state configuration is 1s2, 2s2, 2p2. According valence bond theory, carbon should form two covalent bonds resulting in CH2 because it has two unpaired electrons in its electronic configuration. However, experiments have shown that CH2 is highly reactive and cannot exist outside of a reaction. Therefore, this does not explain how CH4 can exist. To form four bonds, the configuration of carbon must have four unpaired electrons. One way CH4 can be explained is the 2s and the 3 2p orbitals combine to make four equal energy sp3 hybrid orbitals. Carbon atoms usually form bonds by mixing different orbitals and can contribute to the formation of different structures. When we talk about hybridization of carbon, there are several types. So they are sp, sp2 and sp3. The sp3 hybrid orbitals is a blend of one s orbital and 3 p orbitals. So sp3 hybrid orbitals has 25% s character and 75% p character. As mentioned before, the electron configuration of carbon is 1s2, 2s2, 2p2. Let's focus on four valence electrons. So, how carbon forms sp3 hybrid orbitals? It uses all these four orbitals. Firstly, there is excited state. One paired electron from 2s orbital becomes unpaired and jumps to the 2p orbital. And after that, one s orbital and 3 p orbitals combine together to form sp3 hybrid orbitals. So where should be sp3 orbitals? Because the sp3 hybrid orbitals has more p character than s, the energy level should be closer to p than to s. These four sp hybrid orbitals called degenerate orbitals. Degenerate orbitals are those have same energy. In the case of methane, the hybridization of carbon is sp3. The bond angle in sp3 hybridization is 109.5 degrees and the geometry is tetrahedral. The sp2 hybrid orbitals is a blending one s orbital and two p orbitals. We have 3 p orbitals. So one of them don't hybridize and has the same energy. As we said, sp2 has one s orbital and two p orbitals, which means it has 33% s character and 67% p character. So to make sp2 hybrid orbital, firstly, one paired electron from 2s orbital jumps to the 2p orbital, and then one s orbital and 2p orbitals mix together to form sp2 hybrid orbitals. Because the percent of p character is more than s character, the sp2 hybrid orbitals should be still closer to the p orbitals than to s. Ethene is an example of sp2 hybridization of carbon. In the sp2 hybrid orbitals, bond angle is 120 degrees and the geometry is trigonal planar. Please consider anhybrid orbitals always form pi bonds and hybrid orbitals form form sigma bond. In this example, sp2 hybrid orbitals form sigma bonds and 2p orbitals form pi bond. Now, let's talk about sp hybrid orbitals. sp hybrid orbital is a mix of one s orbital and one p orbital. So we have 50% s character and 50% p character. So when the one s orbital and one p orbital mix together, the sp hybrid orbitals should be right between of the s and p orbitals and also remain two unhybrid p orbitals. As mentioned before, a hybrid orbitals used to form sigma bonds and unhybridized orbitals, in this case the p orbitals, are used to make pi bonds. Ethine is the example of sp hybridization of carbon. The bond angle in sp hybridization is 180 degrees and the geometry is linear. Finally, you can see the summary of these three hybrid orbitals in this table.